Hello again, folks. All right, let's dive in. Let's do some Bronsted acid-base identification. This is problem 1 from your sheet. So go get your problem sheet right there. All right, go get that. We got to go through these problems this week. 8 of them. Most of these are pretty quick, so most of them will go pretty fast. So this one, first one, it says identify the acid-base conjugate pairs in each of the following reactions. So these are acid-base reactions. In fact, all of them are what would be called weak acid, weak base reactions. Again, we don't know what that means yet, but we will soon, very soon. So this is an acetate ion. This is hydrocyanic acid or hydrogen cyanide acid, or sometimes called prussic acid. A lot of names. And this one here is acetic acid. Some of you like that. It's in vinegar. I hate it. I hate the smell of it. Yuck. But hey, whatever. This is the cyanide ion. Okay, so we're going to identify. Now, remember, we have arrows going in both directions here. So that means we've established some equilibrium, right? Arrows can go both ways. So our reactants can form products, our products can form reactants. So we can make this, and this stuff can make this. It goes both ways. So always remember, though, the reactants, by the way you're looking at it, are always called the reactants on the left. Although these would be the reactants to form this product, we still call these the reactants. All right, so let's dive in. Overview. Who's the acid? Who's the base? Just start labeling them. Remember, an acid, okay, has to have hydrogen in both definitions, whether or not it's Arrhenius or Bronsted. So this has hydrogen. Yes, it does have hydrogen in it, the acetate ion. However, the H here is out front. Sometimes you're looking for the one out front or on the end. Sometimes it'll be on the end. Okay, the one out front. This is your acid. How do you know? Because it's got hydrogen. That's it. That's all you got to do. This is good. So I'm going to label it. So this is my acid. On the left side, that's the acid. This must be the base. If that's the acid, that's got to be the base. Okay. So, and how do you know it's the base? Okay, well, let's also look at the Bronsted definition. The Bronsted definition says that you're an acid if you give away a hydrogen. So these two react, form this. What happened? It lost the hydrogen. Therefore, this must have been the acid because it became CN without the hydrogen. It lost the hydrogen. It's the acid. This is the base. Why? Because the acetate ion takes the hydrogen and wham, we throw it on the end here. So what did the acetate ion do? It accepted the hydrogen. This took a hydrogen and became that. So it accepted the hydrogen, you are the base. That's the Bronsted definition. Okay, now, you know, hopefully at this point, that during equilibrium, you watch the videos, right, from the last section, all that equilibrium stuff. It doesn't go away, so please look at those and understand them. Go through them if you have to again. This stuff, and during equilibrium, will back out and form this stuff. So let's just pretend. So let's do this. So let's take the arrow out. When going to the right, we see that this is the acid, this is the base. When we go back to the left, so now let's look at these. What do these do? These form these, right? That can happen in equilibrium. So who's the acid? Well, you don't have a hydrogen. You're not the acid. It's got to be the base. It doesn't have hydrogen. It's got to be the base. So I'm going to put a B here. And this has a hydrogen on the end. Ooh, that's got hydrogen to give away. That's the acid. That's how I know. Now, if I look at the reaction, what happens? This, the acetic acid, gives away that hydrogen and becomes the acetate ion. It gives it to the cyanide ion and becomes the hydrogen cyanide acid. So going in this direction, we reverse the roles. That's what you do. You always reverse the roles. So who's an acid on one side, on the other side of these equilibrium acid-base reactions becomes the base. You're the base here, you're the acid here, you're the acid here, you're the base here. And that means going back in this direction. These acid and base labels are referring to going back to the left. Okay, those are called conjugate. Cons means with. So you always have an acid and a base together in these acid-base reactions. And we can identify the conjugate acid-base pairs on the left and on the right. Okay, these are together and these are together. All right, let's go on. Let's try this. Here we have bicarbonate. I have two bicarbonates. They're the same. Who's the acid? Pick one. Just pick. It's like a toll booth lane. Pick, stick. Don't change lanes, because when you do that, the other lane goes faster than when you're in. You know this is true, right? You know it. So pick and stick. It doesn't matter. One of you are an acid, and the other one's going to be a base. And since you're identical, it doesn't make any difference who I call the acid or base. Call you the acid and you the base. Okay. Now what happens on this side? They're different, right? Okay, so what happens? If you're the acid, you gave away your hydrogen. And if I give away that hydrogen, let's just put the arrow going to the right, what am I left with? Ooh, the carbonate, yeah, you gave away that hydrogen and became that. You didn't give away a hydrogen, you took it. You took it from this one and became that. So that's the acid, that's the base. They're identical, so you just go ahead and pick one. All right, well, let's try it the other direction. Let's say that these two are reacting to form those two on the left. Okay, who's the acid? Well, it ain't you. You don't have any hydrogen, so you've got to be the base. And remember, if you choose one, on one side to be an acid, the one on the other side will be the base. Although this one is kind of weird because they're the same. Okay, what about you? What are you doing? Well, you have hydrogen. So you're an acid. That's carbonic acid. So I got some carbonic acid here, and it's going to, in this direction, give away one of those hydrogens. It gave away one and became that. And then when it gives it away, that becomes that. So going to the left, you're the acid, you have the hydrogen, and you're the base, you don't. Okay. All right, those are the acid-base pairs for number 2. And number 3, we have some dihydrogen phosphate, which is a weak acid. Well, we've already mentioned this, that bugger here, right? We mentioned that. That's a base. That's ammonia. It's a base. It's a weak base. Important to know that. So, I mean, immediately I know this is a base because it's ammonia. So I'm going, all right. You're a base. You're ammonia. You're an acid. You've got hydrogen. Well, it's got hydrogen too. Yeah, I know, but it's a base. Sometimes you just have to know things. Sometimes you just have to know certain things. One certain thing you just have to know is that NH3 is a base. Just got to know. So that is my acid. It's going to give away one of those hydrogens, and what happens? Yeah, it gave away a hydrogen. See? Here it had 2. Here it only has 1. And you were NH3, and you became NH4. You took it. You accepted it. So you're the base. All right, so that's going to the right. Let's go back to the left. If these two things are in equilibrium, these are going to react and form some of that. So going to the left, well, let's see, who's the acid? Oh, interesting. This is not ammonia anymore, it's ammonium. And ammonium is a weak acid. It is. But that's got the hydrogen. True, it does. But that doesn't mean it won't accept one. It can. This one has an extra hydrogen on it. Ammonia is a base. Ammonium is a weak acid. Remember that. So, and you can see what happens. This NH4 gives away a hydrogen and becomes NH3. So it lost one. It donated one. So it must be the acid. So going in the opposite direction. And again, these are just opposites to each other, right? On one side it's a base, and the other side is an acid. It's the easiest way to remember it. If you identify one of them on one side as being an acid, then the conjugate is going to be on the other side, going to be a base. So this is HPO4, and it gained that hydrogen. So this accepted the hydrogen. So going back to the left, we have this being the base. Again, opposites, opposites. Okay, that's how we identify our acids and bases. Look out for the hydrogen, and then look to the other side and see who gave away that hydrogen. You're the acid. And see who took it. You're the base. All right, I will give you on our next exam, next academic adventure, shouldn't say exam, it's a dirty 4-letter word. Our next academic adventure, I'll give you some of these to identify. And you identify them, and you'll be good, okay? This is a good video, good time to stop, right? See you soon.